Thanks, everybody. It's really exciting to be here, and the sessions so far have just been great. So much data is being created. It's just really exciting to see how FaceBase is growing. So I'm happy to be here today to talk to you about our project for FaceBase. And this is called a Human Genomics Analysis Interface. And this project was sparked by the fact that there are now many data sets of human genomics data with respect to craniofacial, oral, craniosynostosis, other data sets. Lots of data sets out there. And it's not always easy to get access to the raw data. You might want to do a quick scan of what kind of results have been found for a particular phenotype, for a particular type of panel, whether it's GWAS or sequencing or whatever. And although the power user can readily go into dbGaP and pull down the raw data and calculate whatever they want, other people might just want to look up results. Those could be, human geneticists. Now that we've created this tool, my lab uses this all the time. It could be someone who has found an interesting gene expression in an animal model and would like to know what it looks like in the human data. Furthermore, not every genomics analysis for craniofacial traits has been done in the US. So we have a lot of collaborators in Europe, China, wherever, that obviously do not deposit their stuff in dbGaP. So we see this as an umbrella that could be used for creating a nice lookup interface for wide projects that are already out there, so existing data and results. So the goals were to develop a software interface for doing this, for looking up human genomics results, with no necessity for access to individual level data. And indeed, we won't do anything with individual level data for FaceBase. It needs to be set up in a very secure hardware situation. Another goal was to identify appropriate genomics projects to include in this tool. And we've done that through our own research from our collaborators in the craniofacial research community, in data sets that are in dbGaP, in hunting down publications that imply they may have data that would be useful for this. And then the ultimate goal is to create and display results from these genomics projects. For example, showing Manhattan plots or locus zoom plots. So in the first year, we basically decided what our approach was going to be. We got our hardware all set up. We got all the necessary security certifications and so on, created the basic software. Then in this past year, we really brought the website up. This year, last year at the annual meeting, we had some mock-ups of what the website was going to look like and talked a little bit about our approach. Now it's been created and actually updated a couple of different times. We've identified a long list of projects, and we have several of them that are available now through the website. And we created project pages for all of those that we now have in hand. We created the necessary results databases and put together the interface for each of these projects. So that required a lot of specific work because everything was sort of unique. Each project that we pulled up had its own unique features, so we had to do, some unique programming for each project that we're incorporating in the tool. So when we first set out to do this project, we had envisioned that basically analyses would be done on the fly. We would give the user options they could choose, and then p-link or something would churn away in the background and come up with the results. Well, we quickly realized that there's a lot of ways you can go wrong trying to run your analyses on the fly. It takes a long time. It can take a long time for one. There's a lot of mistakes you can make in setting up the runs for another. So we decided the best thing to do was to pre-calculate the results databases. For example, p-values at SNPs for a particular analysis. We would pre-calculate all of these for any relevant subsets of our data, and this will be clearer when I show you some of the actual pages. For many of the projects, there's groups by ethnicity, by the types of SNPs run, by phenotype, by environmental factors. And then we also customized what we were going to display working with our collaborators. So for example, some of this is very new. So the investigative groups just wanted the published results displayed at this time. And then as more results are published, that options will be added to the project page for those projects. We also as part of pre-calculating the results databases, we also pre-calculated the Manhattan plot files for all of the relevant subsets, again, to save time. Then we also have customized scans of the results databases, primarily using LocusZoom, and those were left to calculate on the fly. However, it can take a long time to run a LocusZoom, so we also pre-ran typical requests, and I'll kind of tell you what I mean by that as we get there. So this is the website, which is located on our computer network at Pitt. So it's also available, the link is also available on the FaceBase homepage and on our FaceBase project page. So to avoid sort of the jinx of live demos, I've pulled screenshots to go through, but feel free to bring it up and play with it while I'm talking. So this is the landing page. So we have various projects. So if you click up here, you can pull down a list of all the projects that are available, our data usage, language, FAQs. And then we've grouped our projects into 3 main groups for now: oral facial clefting, facial variation, and dental traits. As we move forward, there may be additional groups, maybe non-syndromic craniosynostosis. I know there's a couple GWASs out there for that. Then basic information about the project in general, with live links to the FaceBase website, to NIH Reporter for the grant. So if we clicked the oral facial clefting icon, it would bring up the list of projects that we now have live for oral facial clefting. We have 3 GWASs right now and 1 set of targeted sequencing. If you then come back and click on facial variation, the 2 projects that we're working on right now are not live yet, but these were both projects that were part of FaceBase 1. So the first is the 3D facial norms that Steve Skolnick mentioned earlier. So the phenotypes for that project are available on the FaceBase website, as well as some statistical analyses of those phenotypes. The GWAS results, though, are in dbGaP. So using this tool, you'll be able to scan the results from the 3D facial norms. Similarly, this was Rich Spritz's project in FaceBase 1. It's the Tanzanian data is available here. And in the 3D facial norms GWAS, there's also Caucasians from Dr. Spritz's project. Then dental traits is a recent addition. Right now we have some of the GWASs of dental caries, but we're planning to look at other oral traits as well. Okay, so let's go back to oral facial clefting. We have the most results up for that, and I'm going to just walk through a couple results of what the project pages look like. So this is the most recent one that went up. So here's the project page. So again, on the project page, we have the dbGaP study accession number. If you click on this, it'll take you to dbGaP. So if you do want to go get the raw data, that's where you can go. Basic description of the project. The methods tab for each project just gives a brief summary of the methods that were used to come up with these results. And if necessary, a link to where you can get more methods, more detailed methods. The descriptive statistics tab gives you some basic frequency counts for the variables in a particular study. So for here, this is again an oral facial cleft project. So it shows how many have cleft lip alone, how many cleft lip plus palate, how many cleft palate alone. There's also tables by gender, by ethnicity, et cetera. Then the Explore Project Data tab is the meat of the tool. This is where you can click what you're interested in and get results to look at. So we have sections where you can choose aspects based on the particular study. So for this study, you could go with just genotype SNPs, or you could use the full imputed batch of SNPs. You could use all the ancestry groups, or there's Asian, European, Central South Americans. You could do cleft palate alone or cleft lip with or without cleft palate. In this particular project, we had a set of trios and also a set of case controls. So you could look at just the trios, just the case controls, or you could look at a meta-analysis combining those two non-overlapping subsets. And the types of output that are available are a Manhattan plot of the subset of families that are included in whatever, checkboxes you checked, or you could do a more customized search using region locus. So these are unique to each project. So now if we look at this other project that was Terry Beatty's GWAS project in the Geneva consortium, we have a section for viewing the published peaks so that you don't have to necessarily pull up the paper to see what was originally published. Then for the other plots, you could have genotyped and imputed. It was initially done with human genome 18, but it was also aligned with human build 19 as well. So you could choose one or the other. The phenotypes could be everything: cleft lip with palate, palate alone, lip with or without palate, palate with or without lip, etc. The Asian and Europeans were the subgroups there. And they also had environmental factors. So we have kind of a simple environmental test here where you can choose the subset where mom smoked during pregnancy or not, where they had alcohol or not, where they had used vitamins or not. And again, Manhattan plot or locus zoom. This is the project of some targeted sequencing data. And again, some choices. There were just certain regions that were sequenced in this project, so those are highlighted here. Okay, so going back to this most recent one, we've got genotyped, all ethnicities, cleft palate alone, trios alone, and we want to see a Manhattan plot. And the Manhattan plot comes up at the bottom of your page. You can also click on the Manhattan plot to bring up a PDF, which you can then download. Here's just another run where we did all the imputed data, all the ancestry, cleft lip with or without cleft palate, meta-analysis across all the data, basically, another Manhattan plot. And again, this pulls up a PDF that you can download. And we got some nice results in that study. Okay, now along the vein of protecting the users from themselves, if there's not enough data for meaningful results, you'll get an error message. So in this particular project, we didn't have very many Asian trios. But this user clicked Asian and trios, and when you try to submit it, it'll say it represents a low number of trios, so a graph was not generated. Okay, now how about the exploring custom regions? So again, just clicked a few buttons, and you can enter either a gene name, you can enter a SNP name, like an RS number, or you can choose a chromosomal region. So here's an example of looking for IRF6 in the cleft palate families, and it brings up locus zoom. So here's IRF6. There's no signal here because it's cleft palate, not cleft lip with or without cleft palate. Or you could have asked for the chromosomal region. They did have to enter the whole thing, but it's kind of just cut off by the block here, but the whole region is up here. Each of the PDFs that's created, whether for a Manhattan plot or a locus zoom, has a little summary up here of what you chose to create this plot, so it's part of the plot. Okay, so on the project description page, we have, for example, live links to dbGaP, again, to just bring up the dbGaP page for this project, to go in to look at a little more detail about the project, or even go so far as to request the data. What else did I put in here? Okay, another tab is publications. So for this tab, we created PubMed searches for each of the projects so that it will always be up to date. So for example, one of the general search terms we use is the grant number that created the GWAS or whatever. So this is one of the new projects, so only one thing comes up, there's more coming, but if there were multiple pubs, they would all come up in a list, as usual in PubMed. Now, we've just started tracking through Google Analytics visits to this site, and this is not a very thoughtful use of Google Analytics yet. It's just very quick and dirty summaries. So we're hoping to improve our use of analytics and so on to see what kind of use we're getting in the site. For example, look at this bounce rate. We don't like to see that. But this is since October when we first brought the website up. So there could well have been a lot of robot activity or something that led to just one page. Since February, this has gone down to more like 45%, similar to the hub. And there have been 2,500 page views, but again, a bunch of those are these one-shot deals. And this also does not correct for Pittsburgh or the developers. So we'll try to get our numbers in better shape soon. But I have to say that although a number of these returning visitors will be Pitt people, we seriously use it for our research a lot. So it's very handy. And it's coming from a lot of places. These Russians might have been the bots. Who knows? Okay, so in the coming year, we have a number of projects that we're in the middle of getting up on the site. So we have some other OFC-GWAS data from Children's Hospital of Philadelphia, for example. We have some Chinese collaborators that we're negotiating with. We have the U.S. facial variation projects that I mentioned. We have most of the work done for the 3D facial norms, and we'll be working with Dr. Spritz and his group for the Tanzanian results, but those won't go live until the initial papers are published. We have some additional dental and oral phenotypes that we're working on. We're also continuing to seek additional projects, like we're working with some of the Europeans who are also doing facial variation work, and we hope that they'll be willing to have some of their data displayed. And I think it really helps that our tool can be very customized in terms of what the PI would like to allow people to see. So we hope to incorporate some additional functionality and hopefully get a lot of ideas here from this group. We want to, especially as we move forward with new data, we want to be able to have the tool cited in papers that present results that are going to be part of these results databases. For example, the project that I was going through, this most recent cleft GWAS, has 2 papers that were just accepted, and each of those papers cited this link. You can go, so people can know that they can go to this results database and explore the results further. You're never able to put all your results in a paper, no matter how big your supplement is, so having this as an option for people to go to is helpful. And I also want to talk to NCBI about putting something into the dbGaP page for each of these projects that would provide a link to the tool, again, for further exploration of the results from the data. So someone who goes to dbGaP sees that there's this project they might be interested in. Are they really interested in it? They can go look at the tool, scan some of the results and see if it's something they want to go to the trouble of downloading from dbGaP. Then now that we have our basic programming, we have the basic website, we've populated a lot of pages on the website, we want to work more closely with the hub now to get this integrated more fully into the other FaceBase projects. So I love seeing the video that's on YouTube of how to use FaceBase. So it could say, there could be something in there like, wow, I see you're now interested in MSX1. If you go to this human genomics tool, you could see what some of the results are for MSX1 in human data. Or when someone's been scanning expression databases in the mouse or zebrafish on FaceBase, I don't know how it can be done, but perhaps there could be some sort of just a little thing that comes up saying, if you'd like to see what this looks like in the human data, here's a place you could go and look. Further, right now, it's a little unclear how to incorporate metadata or other tags for a project like this. And I was very quickly talk to Melissa a little bit and hopefully can get some ideas from other people on how best to do that. Because right now, the search engines in FaceBase don't find this at all. I mean, there's no metadata for it. So if you go to, so you're able to go to, human organism and then do a search, but nothing at all comes up about this tool yet. And of course, because there's no metadata for it. So I'd like to see that happen. Again, Steve had mentioned the Kids First. That's going to be a big project, trying to decide how best to incorporate whole genome sequence data into a tool like this. What aspects of it would be most useful to present. A lot of that'll go into, browser tracks or whatever, but still there could easily be some ways we could incorporate sequence data. And then finally, it's been a lot of work to do the pre-calculating for all the different subsets in each of the projects. So one important thing that we're going to be working on this year is coming up with standards for getting data from the people we're collaborating with so that we get everything we need to not have to be going back and forth or to not have to calculate every single thing ourselves. So that will be very important to be able to quickly get new data into the tool. We also have a little more testing to do, refining things like the analytics, making sure every browser we can think of can access the site. Okay, so we're really happy with how far it's come and think it can be a really useful tool if we can get it to be, known to the craniofacial research community. So it's fantastic that it's part of the FaceBase project, because that's obviously the ideal way we hope to reach the community. So again, I hope if there's still time, we might be able to get some more questions, suggestions, requests. I want to thank everybody who's worked so hard on this, some familiar faces in the staff and students. And Dr. Leslie's been really instrumental in helping conceptualize how this could be of most use to the community. Eleanor Feingold is a human geneticist who's one of the co-Is on the project. Harry Hockheiser, again, familiar to many people here, who have all provided great input on how best to set this up. So again, thanks to all of them and thanks to you. So please, if there's any questions, just let me know. Anything you'd like to see in such a thing?
Yeah, thanks, Mary. So, yeah. Okay, we got a question from Rich.
Hi, Mary. Very nice.
Hi.
So I understand how it works with your own data, and I understand how it would work when you're working closely with whoever did the work. But I wonder about subject QC and post-genotyping SNP QC. So, for example, what goes into dbGaP usually does include individuals who are removed from the analysis because of post-genotyping SNP QC, and you won't know that necessarily. And I don't see how you know what SNPs were removed in post-SNP genotyping QC or post-genotyping SNP QC. And then at a more complex level of analysis, if there were public data sets that were used in a case control analysis, for example, then it would seem you have no way of knowing any of the QC that would have been done. How are you thinking to handle that?
So far, we have not gone to dbGaP itself to download data. We've worked with the investigators. So we rely on them to either provide us with data that is post-QC, or in some cases, we're not able to get the data for whatever IRB reasons, and we request the p-values for the runs that they want to have displayed. So we're not trying to say we're doing that we're changing any analyses that these investigators had done. So it'll still have whatever pros and cons of the analysis that investigator did. But it's trying to give, a lookup, a scan of the kind of results they reported, or the results that they didn't explicitly report, but that are buried in their results. Did I say both questions? Yeah.
Have you tried to get the craniosynostosis GWAS data?
Not yet.
Yeah, we should try.
But definitely would like to do
that. We have some of it, but Samantha Boyd has the bulk of it at
Great.
UCDenver.
And of course, that's one of the themes of this time around for FaceBase.
The other question I have is often, Can you hear me?
Yes.
The other question I have is a lot of clinicians will see a case, they'll find a VUS, a variant of unknown significance, maybe in a cleft palate patient or some sort of craniofacial patient. It might be nice, I don't know, it's a whole new project, but I'm saying to have people enter in these cases somehow. So you'd be able to interpret sequence data or SNPs or CNVs and things better, collecting data like that, like they did for BRCA1, BRCA2, things like that. Mm-hmm.
That would be a rather different project, and that would have some intersections with what Dick Moss and Rich Britz are doing within FaceBase, which we'll hear more about. But yeah, the more types of tools we can have for clinicians would be in sort of lookup category to see what's already out there.
Okay, great. Thanks, Mary.